So in this video I'm going to do the examples of plotting exponential and logarithm functions. I'm going to go ahead and do both in this video. And on both of them I'm going to use my calculator eventually to help me draw the pictures, but I'm going to also look at the asymptote and the domain and range. I'm actually going to do that first without my calculator to show we can think about these algebraically. Okay, let's get my pen set up here. So on this function, this is an exponential. We've got our base raised to the power here with x in it. That's an exponential function. The domain of any exponential function is all real numbers. So I don't have to do any computations or think too hard about that. When it's exponential, the domain's all real numbers. For the range, I could either punch the graph into the calculator and look at it, or let's just review of transformations. Let's think about what the graph's going to look like. Okay. So the base is less than 1, we're going to get exponential decay if we just did 1/2 to the x. Okay? But if we do the x plus 5, that would shift it back by 5, to the left by 5. And then the -3 has a really big effect here. It moves the asymptote. I'm going to change color and draw my asymptote in here. Oop, -3. Okay, so we're adding a -3 or subtracting 3. It'll put the asymptote down. The asymptote, a horizontal asymptote's at y equals -3. On the exponentials, they're always controlled by the vertical shifts there. And then the graph would look something like this. So the range, it always depends on where the asymptote winds up and whether or not it's been reflected or not. Here, it's from the asymptote up. So that would be parentheses because you don't hit the asymptote, -3 off to infinity. Okay? And then let's just try to draw a better picture of this with the help of our calculator to be a little more accurate here. Okay. This part, I'm trying to get used to this pen that I have that allows me to draw on the computer screen, and I'm writing down on the tablet, it's showing up on the screen. The really hard part's doing this. And my hand is not writing directly on the graph, so not too bad. That's actually probably the best I've done yet on drawing one of those. But there's my attempt to draw the axis in. And I'm just going to say down here that the scales are 1. The x and y scales are both 1, so we don't have to label a lot on the picture. But we have the asymptote at -3. You always want to draw your asymptotes as dotted lines, unless they land on the x or y axis, which are big solid lines. And yeah, let's just get a few points from our calculator. So I'm going to pull up my calculator here and do y equals, let's see, -3 plus parentheses 1/2 to the x plus 5. And we could verify everything we've said, that you have the asymptote at -3, the domain's all real numbers, the range is from -3 to infinity. And then I'm just going to get a few points. It's almost at -3. It's going to be really close. If I do trace and do 0, my y-intercept is very, very close to -3. Let's get a couple more points over here. If you count over, it hits between -6 and -7. We could do the x-intercept. That's probably enough. Let's draw on here. You just need a couple of points. It's going to be really, really close to the asymptote. And then 1, 2, 3, 4, 5, 6. You know, if we wanted the x-intercept really precisely, we could use the calculator and the 0 command. But we're just trying to do a nice sketch here. So I'm just going to try to draw the. I don't like the way I curved that one on the end. Oh no. Sorry, back up and bring it back. I don't want to erase too much here. Just getting a little squiggly because of the pen, but I need it to be pointing toward the asymptote on the end of the graph there. So there's my, a little uglier than it would be if I was using pencil and paper, but my sketch of this graph with the asymptote there at -3. Okay, let's try the logarithm version. Okay, so here's a logarithm function. We're going to do the graph, do the same type of stuff. On the logarithm, the range is all real numbers. So -infinity to infinity. They're the inverses of exponentials, so their range is all real numbers. The domain and the asymptote, we can actually focus in pretty explicitly here. The asymptote's going to be where the input, x minus 5 in this case, is equal to 0. So x equals 5, there's where my vertical asymptote is. And the domain is where the input is positive, so where x is greater than 5, so 5 to infinity. Okay. So again, here we go. Oh, I'm going to do a bad job drawing this. I got to retry that. Terrible with this pen at drawing the straight lines over top of these things. There we go, not too bad. So we have an asymptote at 5. 1, 2, 3, 4, 5. Then we're going to have a logarithm graph here. So let's use our calculator. Get a couple of points now. So y equals, going to clear this one out, and we got 2 natural log x minus 5 plus 1. Graph that, and we'll see the logarithm shape. Remember, I've mentioned this every time I've graphed one like this in class, that's not an endpoint. The calculator plots points, and to handle the asymptotes, the way they've programmed this calculator for some reason is when the points change rapidly, it doesn't connect them so that you don't connect across asymptotes. But the graph really goes down forever there. The range is all real numbers. So when I draw it, I'm going to put an arrow on the end. And then I'll kind of estimate the x-intercept there in front of the asymptote. And let's do another point. I'm just going to pick a value out here, like say 8. It goes through 8 and about 3.2. Okay. So I'm going to put a point out there. So this was 5, 6, 7, 8, and about 3.2. And then the x-intercept was right in front of the asymptote. And try to draw my logarithm going through those points. So there we go. We've got the logarithm function increasing off toward infinity. It does go down toward negative infinity. The range, it's going to cover all possible y values. And then the asymptote is there at x equals 5.